concept and development of Fluidsim pneumatics is based on research work carried out by Dr. Daniel Curatolo, Dr. Marcus Hoffman, and Dr. Habil. Fluidsim is a comprehensive software for creating, simulating, teaching, and learning about electro-pneumatic, electrohydraulic, digital, and electronic circuits. With more than 200,000 installations worldwide since 1995, Fluidsim is one of the most successful software packages in the mechatronic training. Learning objectives. Identify the functions of Fluidsim, enumerate different components for pneumatics, perform pneumatic simulation, single-acting actuator using Fluidsim, value Fluidsim as a simulation software for pneumatics.
So, good day to everyone. My name is Kenneth Evasco Torres. So, here, this is the function of Fluidsim software in pneumatics using these toolbars. So, here, we can see here the different kinds of toolbars. So, here we have file, edit, execute, the library, insert, didactics, project, view, options, windows. So we will focus more in here. Why? Because if I click it here, you cannot see it in your in the screen, but all of the functions of these toolbars here can be seen in this part. So first and foremost, you can see here that I have already put a list of components here into our diagram. So of course, we need a new one or a clean one. So we can use Control A or Control N rather, and or click the upper left corner, which is an icon of a paper, which is called new, for a new paper. Here we have a new one. So we can also open or use Control O for opening previous files or new files from our other work here in our Fluidsim. So here we can choose in here, okay, and of course we can save it, which is its shortcut is Control S, our file. So we can also use the circuit preview for previewing our previous circuits, in which is here the didactics, material, digital technique, crop set, and etc. And of course we can print it since it's like a word. Our schematic diagram in Fluidsim, using Fluidsim rather, in pneumatics is printable. And here in this part, we can this is the part where we can edit our components. For example, I put compressor, but I don't like the compressor air supply. I want the compressor one. So we can just undo it by clicking the undo sign or alt backspace. Okay, so we can put the compressor. Okay, but what if I don't already like using compressor? Of course, we can cut it by clicking the scissor sign or Control X. Okay, so here, how about copying it? So we can copy it by Control C or copy, and we can paste it by Control B. Okay, understood. And now we can also align it. So we can align it here into our left, into our centered horizontally, into right, into our top, into our vertically centered, and to our bottom, according to what we want to our circuit. Okay, the next one is we can also put a grid or display grid so that our circuits and our components are aligned to each other. Okay, like that, and we can remove it. Of course, we can try to view it. Here, this is the part where we can view. We can view it in standard size. We can view it in previous view, which is the view where we're viewing before, and we can fit to it. We can fit it to our window like this. Okay, so sample like that. It's already fit to window, but I want to it back to standard size. So I'll click standard size, but I want to view it previously to our from the fit to window. Okay, we can of course zoom it in rubber band. So zoom it like this. So circuit change. So like that, and we can zoom in and of course zoom out our circuit. Then we have here, check it specifically if it's working, since we only put two um, supply elements. We can see here which one is incorrect, because there's a um, uh, line here or sign here that it's incorrect. So of course we can check it later. Here there's all of course the part where we can execute our task. We can stop it, we can start it, which is not going to start because the circuit or the wiring is not good. Okay, and we can pause it here using this button, pause. Here we can reset it, we can use a single step, we can of course simulate until state change and proceed to our next step. So that's all in this part of pneumatics. The next part is you will understand the component library. So once again, welcome to our class about pneumatics using Fluidsim as a software, simulation software. So now let's view the components library. In our component library, we can see here the my files and of course the common files. In my files, we can see here the digital technique, easy port, and electric, which is will not be using, since we'll be focusing in the common files, which we'll be using here in uh, pneumatics. So here you can click the pneumatic tab to choose which among those uh, components you will be using. For example, supply elements. We have different choices here that we can use. It's either the compressed air supply like this and this. Commonly, we are using something like this. So how do you put it into our sheet or our copy? So you need to click it and long press to drag it into our um, diagram. So we can double click it so that we can change its compressed air, the maximum flow rate, and the operating pressure to our own liking. We can change it of course here differently if what we want or what do we need to our pneumatics. So we can drag our compressed air here. There are so many kinds of compressor or supply elements, like here air service unit, which is occupied representation, air pressure. Here automatic drain filter, manual drain filter, air filter. It depends upon what you need into your schematics, and it depends upon the objectives of your teacher. So here we have air dryer and cooler, lubricator, which can be used for pneumatics. And now, as we proceed, we'll be looking onto the actuators. Actuators are commonly the output of our pneumatics. They are the cylinder of they're called cylinders as well. And here we can click it here and drag it here. We can change it according to what we need. So here you can see here the position, the force, and etc. So I would like to change it into 2 piston. We can change it into 2 piston, and we can look into this part for its what do you call this symbol. I don't want it to be spring returned, so I will change it. We can click it there, and we can put a description here what it is and what does it do, or commonly we put A, B, so that we know which is which. So no piston, we can put it that. But since we'll be trying um, to understand more about pneumatics, I'll be using this example. So like that, we can also use, here we are single acting, we can also use double acting, single acting return spring in piston chamber. There's so many things that we can use. Commonly, I will be using uh, single acting and double acting. I just put it here. Okay, next one is we can see here the frequently used cylinders. The frequently used cylinders are these. Of course, here the double acting and the single acting like this. But it's all the same since it's all cylinders or the actuators. The next part is the bulbs. The bulbs is the solenoid. Here we have 2 to 3 way, 2 to 2 way, 3 to 2 way bulb, 4 to 2 way. We can always check it like this. So let's try to put a cylinder or bulb here. We can change it according to what we need. If it is manually operated, what do we need? Is it a push button? To our right side, is it a here push button, or is it mechanically? Is it using by a roller like that, or here like that? There are so many options that we can do. If it is spring return or it is piloted like that, we can always have different options and functions for our solenoids. And solenoids are useful for um, creating a circuit in which is we can manipulate it automatically, and of course we can manipulate it manually using these solenoids. With our solenoids and our um, cylinders. So of course there's a frequently used bulbs in which is the same as the others, but since it is always used, there are 2 parts: mechanically operated, pneumatically operated, solenoid operated, and all. So we also have shut-off bulbs. Shut-off bulbs are the bulbs that is used for their shut-off. Here's the shut-off like this. We can click it here to make, of course, it close, and have, or like this, we can have this silencer. Whereas we can also put it here, click it, and use it here. We can close it or make it still open, or use a silencer here. Okay, so how can we connect it? We can connect it by clicking the dot, one click, and dragging the line into here, so we can have our connection. Okay, and how about this? So we can still connect it by dragging it and putting it into the line, so that will be connected. Next is, of course, shut-off bulbs and pressure control bulbs. So pressure control bulbs are, of course, kind of bulbs which can control the pressure. There are so many options here. We have valve groups, which is a much advanced way of learning and understanding pneumatics. Here's the measuring tools, the flow meter, and analog uh, flow meter, pressure sensor, and differential switch. It's more on measuring and using sensors. So here, electrical controls, we have here the electrical controls, which is of course including once again the actuators, power supplies, here, DC motor for electrical, power supply of course the 24 and 0 volts which is commonly used in relays, and measuring instruments which is to measure once again, for example here the voltmeter to measure the volts, ampere, and the light. Here's the buzzer, and here the relay, since relays are connected to our electrical or mechatronics electrical controls. Here of course in pneumatics we need switches. In our switches there are so many kinds of switches. There's manually operated like push button. Here the 10th switch changeover, more on push button, we're using more on push button. General switches, which is the common switch that can be used in relays. Proximity switches, here the capacitive, proximity switch, magnetic, inductive, and optical. And here's we have here the controller, which is a much advanced in pneumatics. We have here the more advanced, the port, digital techniques, and graph set, and of course the miscellaneous. So overall, Fluidsim gives us the variety of understanding and learning pneumatics using the simulations. And in these so many kinds of components, we can use it for advantage in teaching and learning pneumatics in this type of era, where is computers and laptops are now very helpful for each and everyone, especially for teaching and learning. And in this case, we can enhance more and we can use it to our advantage as a future teachers and for our students.
Good day! This is the simulation for single acting cylinder. So, first, naglagay muna ako ng compressor galing sa ating component library. Then, naglagay tayo ng air service unit. Yung air service unit, optional lang siya. So, naglagay ako ng air service unit para lang ipakita na yung hangin natin mula sa compressor ay kailangan malinis at ma-filter. At malagyan ng sapat na pressure para sa ating gagawing simulation. So, naglagay ako dyan ng 3 to 2-way bulb. Then, double click lang natin yung terminal number 3. Then, gagawin natin siyang exhaust. Then, double click the valve. Then, lalabas itong configure way bulb. Then, pwede natin i-customize yung kung manually operated ba siya or meron ba siyang spring return. So, dyan, nilagyan ko siya ng manually operated, which is yung push button. Then, nilagyan ko siya ng spring return. Pag i-connect lang natin siya, double click lang natin yung bilog, tapos connect natin sa isang bilog. Then, kumuha rin pala ako dito ng single acting cylinder. Then, kinonect ko lang din. So, pag sa-simulate na natin siya, pag clinic natin yan, yun, mag-e-extend na yung ating single acting cylinder. So, good day everyone. This is the simulation for double acting cylinder of pneumatics. So, first naglagay lang ako ng compressor mula sa ating component library. Then, naglagay ako ng air service unit. Yung air service unit, kaya nang sabi ko kanina, optional lang siya. So, kinonect ko lang din. Connect natin yung isang bilog or isang terminal papunta sa compressor. Then, kumuha ako ng 3 to 2 way bulb galing sa configurable directional bulbs. Then, click terminal number 3. Then, gagawin natin siyang exhaust. Then, double click natin yung 3 to 2 way bulb. Then, lalabas yung configure way bulb. Then, pwede na natin customize yung mga functions niya. Which is, pwede tayo maglagay ng push button. And, naglagay din ako dyan ng spring return. So, kinapi ko lang siya, then pinaste para maging dalawa yung ating valve. Then, kumuha ako ng 5 to 2 way valve. Yung 5 to 2 way valve, parang magsisilbi siyang way or connector ng dalawang ginawa nating 3 to 2 way valve. So, dyan ginawa ko lang exhaust yung panglimang terminal at saka pangatlong terminal. Then, ginawa ko siyang pneumatically and electrically controlled, which is yung air piloted. Then, connect ko lang sa dalawang valve. Then, galing sa service unit, connect ko lang sa dalawang valve, which is yung 3 to 2 way valve. And pati yung ating 5 to 2 way valve. Sinuplayan lang natin siya ng power, no? So, next, kukuha na tayo ng ating cylinder. So, kukuha tayo ng cylinder sa ating sections for cylinder. So, yan. Actuators. So, dahil double acting cylinder tayo, kukunin natin yung double acting cylinder. Then, connect lang din natin yung terminals niya. So, pagka-connect natin, pwede na nating i-test yung ating ginawang simulation. So, to test, click lang natin itong triangle na to sa taas. Then, ayan, pwede na nating simulate. So, pag-click natin yung switch 1, mag-extend. Pag-click natin yung switch 2, magre-retract. So, ganun lang siya.
Good day to everyone. So this is an actual components in pneumatics. Here's an example of our cylinder, which is our actuator. Then our solenoid bulb that we will be using. We have Y1, Y2, Y3, Y4, Y6, and Y5. There's also shut-off bulbs that you will be using to turn off those extra air. So now let's proceed to our tubes where we can connect our compressed air and of course our rabbit wire for connection purposes. Next one is our air supply unit. Our air supply unit is called June Air, which has 220 volts and 60 hertz. We'll be using it to supply our project for today. It's connected to our solenoid. Our next component is of course our switch. Our switch is an actual switch. It's normally open together with our power supply. 9 volts power, 24 volts power supply, connected and ready to go. So here's an example of already done wiring diagram of a single acting solenoid. And later, I'll be discussing you the step by step making one, and it was used, or it was created by using the Fluidsim software um, simulation practice in its diagram. So here's an example. And now, first of all, we need to put a power supply or positive supply to our switch. So I'll be using two switches because the switch is already um, broken, so I need to troubleshoot it and make it two, because when I turn it off, it just turn off, and when you turn it off, it doesn't turn off, so I need to use the switch. So here we can connect it to our solenoid, which is in this place, and it is the solenoid is connected, of course, to our power supply. Then the common of our solenoid is connected um, to our cylinder, which is of course connected also to the other cylinder, in which it can extend and then it will retract. And the common of our cylinder is connected to negative supply of our amplifier, or in our power supply rather. So now let's finish our wiring. Make sure that the tubes are connected to the solenoids and there's no leak into the um, air supply. Of course, turn off first your power supply and uh, the air supply, so that your wiring or the components do not have a problem for safety measurements. So here I fix it. Then it's a sample of a single acting cylinder using an actual trainer of pneumatics. I turn it on, it will retract or extend rather, and turn it off, it will retract. So that's the purpose of a single acting cylinder. Next one is the double acting cylinder. Likewise, to our single acting cylinder, we'll be using uh, switches, which is connected to our supply, which is turned off before we start our wiring. So I'm using four switches, for two for turning it on and two for turning it off, because the switch is not um, compatible with our task. But since it's a troubleshoot practice, it is useful for us as an um, electronics tech major. So now I connect it. The first switch, I connect it to Y2, to our solenoid in the upper part, and Y1 solenoid in the lower part of our solenoids, lower left. So likewise, switch 3 and switch 4. Then it's A plus and AB will be connected to our A plus, B plus, A minus, and B minus will be connected to our cylinder. So if we will be using Fluidsim software, we can put legends or markings in our diagram, which is very helpful for us to understand where is the A plus, the A minus in the part of our cylinder, and the Y1, Y2 of our cylinder and solenoid. So now I continue to connect it to the cylinder, and now I'll be trying to put the common, which is the negative, to our power supply. So that's the common, which is negative. Okay. And now as we proceed to our wiring, I connect it using a jumper wire or rabbit wire. So continuous. And now let's try our wiring. Let's open our power supply and our compressed air or air supply. So the first cylinder is active, it is working, it is extending and retracting, and now the other cylinder is much faster than the first cylinder because it needs some fixing on its calibration. So both cylinders are working as you can see and as I operate. Thank you for watching.